Evaluating reorder points is all about distribution of demand during lead time. You cannot assess a reorder point unless you know something about the distribution of demand during lead time. This problem is a classic example of that. Let's look. A warehouse stocks 3 different items, SKU1, SKU2, and SKU3. Okay, information about each of these items is provided in the table below. So SKU1, SKU3. Now, the information concerns the daily demand for that item and the lead time for that item. And notice that the details vary, because in the case of the first item, it looks like the daily demand is constant. See that? And yet, lead time is normally distributed. That means the lead time is variable. Whereas with SKU2, lead time, daily demand is normally distributed. It looks like it's daily demand that's variable, yet the lead time is, see the word constant? Constant. And when you're looking at the details of SKU3, daily demand is normally distributed, daily demand is variable. And lead time is normally distributed, lead time is variable. Oh, okay, so first off, before we get any further into this problem, notice that we have 3 different items, and we have 3 different cases of the kind of distribution that you could run into during lead time. We have constant demand and variable lead time. We have variable demand with constant lead time, and we have variable demand with variable lead time. Now, you're thinking, fine, what am I supposed to do with that? Well, hold that thought, because we should look at what the questions actually are. Now, before we get to the questions, there's one last little fact that's been snuck into the problem. The warehouse uses the same reorder point for all 3 items. ROP for reorder point. Oh, interesting. We're not going to have to find a reorder point here because it's been declared. For each of these 3 items, when they feel they need some more, they reorder when they're down to their last 120 in stock for each of the 3. Okay, fine. Now, what is it that we actually do have to answer? Let's look at the first question. How much safety stock is implied by this reorder point? Now, we were just remarking that the reorder point was 120, and we remember that a reorder point, one way to think about it is average demand during lead time. Now, what I wrote was mu, the classic symbol for average, DDLT during lead time, plus safety stock. Because safety stock is the amount that we reorder at that's above, on average, what we generally need during lead time, right? It's the bump up or the difference between when we reorder and what on average we usually need. Oh, okay. Now, in this problem, notice that we already have that answer. For each item, we know that we're going to reorder at 120, and the question is over here, what's the safety stock? So in order to answer the problem, we need to first determine, well, what is the average demand during lead time for each of these 3 items? Oh, okay. We need to determine what is the average demand during lead time for each of these 3 items. Then we come back and we actually answer the question about safety stock. All right, let's see. Back to here. In the case of SKU1, the first stock keeping unit, average demand during lead time, well, that would be, in a certain sense, you could think of it as logic, daily demand times the length of the lead time. Because on average, how much are you going to need during lead time? Well, how much do you need each day? And on average, how long is lead time? Oh, all right, let's just fill in those numbers. So for the case of this is SKU1, it says demand's constant at 25 units a day, and lead time's normally distributed with an average of 4 days. So on average, we need 100 of that particular item during lead time. All right, so now we have what we need to determine the safety stock for SKU1. Why don't we go ahead and do this logic, though, as long as we're on this page, for the other two stock keeping units, because we're going to need to do that as well. Okay, SKU2, average demand during lead time. Well, it's all about what do you need each day times how many days do you have to wait. So, okay, in the case of SKU, daily demand is normally distributed with an average of 25 units a day. So on average, you need 25 units a day. And what's going on with lead time? Lead time is constant here at 4 days. Oh, okay. So SKU1 and SKU2, they both have the same average demand during lead time. On average, in both cases, we need 100. Let's look at average demand during lead time for SKU3. Daily demand is normally distributed with an average of 25 units a day. Okay, 25 times lead time is normally distributed with an average of 4 days. Oh, so in the case of each of these three items, the average demand during lead time is 100. Oh, which might explain why the company was using the same reorder point for each one of these items. They do have that in common. All three of them, on average, you need 100 a day. Now, wait, go back to the question. We have to answer the question still. The question wasn't about the average demand during lead time. It was a question about the safety stock. And we can answer it in one calculation because it doesn't matter which item you're talking about. The average demand during lead time is 100. This is essentially the X, what we're looking for. So safety stock would be the difference between the two. It would just be 120 minus 100, or 20 units. And that answer is good for SKU 1, 2, and 3. All three of them. They all three have the same safety stock implied in their reorder point, 20 units. Oh, okay. Now, I wonder if we can answer the next question just as simply. It says, what is the service level provided in this reorder point in the case of each of these three items? Oh, okay, service level. I'm going to have to drop back to memory here for a moment. Now, service level, the probability that you'll have enough demand during lead time is normally distributed. That's what I'm trying to sketch here. With a certain average demand during lead time. That's what we've been talking about up here, right? And a certain standard deviation in demand during lead time. That's what basically describes the shape of the curve. Oh, okay, so this is in essence an image of demand during lead time. Oh, and I can keep going with the image because the average demand during lead time here was 100. And we have just placed a cut, in essence, on that distribution with the reorder point of 120. Now, what do I mean by that? I wanted to illustrate the service level. The service level is the probability that you'll have enough. If you reorder at 120, what's the probability that you'll actually have enough during lead time? Okay, the probability that you'll actually have enough is the same thing as the probability that demand during lead time will be less than or equal to the reorder point because you left enough. That is the same thing as the area, the proportion of the area of the normal curve that's actually conveniently to the left of the 120. Okay, now this is three questions, one for each item. Each of the three items has a mean of 100 and a reorder point of 120. I wonder if it has the same service level. Because, now wait, let me think, how am I going to find that area? I'm going to need to calculate a z-score in the case of each one of the items and look that z-score up on the z-table, and the z-table reports to me that kind of area. Oh, right, all right, now z-score, yes. For each one, I'm going to need to say reorder point minus average demand during lead time divided by the standard deviation of demand during lead time. That is essentially a z-score. Or more simply put, x, the number that you're interested in, minus mu, divided by the standard deviation. I need to calculate this one for each stock keeping unit. The number would be, or the value would be the same as long as the standard deviation, the standard deviation in demand during lead time. I can get all set up to do this over here, right? For instance, SKU1, I would say 120 minus 100, but the problem is what do I put in the denominator when calculating my z-score? Oh, well, I got started on it over here, the z-score for SKU1, but that was a little premature. I better drop back to the old sheet here, because we need to determine what the standard deviation in demand during lead time is for each one of these items. Turns out that their average demand during lead time was the same, but is their standard deviation in lead time the same? Okay, now, in the case of SKU1, demand is constant, the lead time is variable. That means that the formula that I need to determine what the overall standard deviation in the distribution of demand during lead time is I need that constant daily demand, and I need to multiply it times the standard deviation in the lead time. Sigma sub LT is the standard deviation in the lead time itself. Oh, all right, so I just need to retrieve those numbers. Okay, well, the daily demand's 25. And it said a standard deviation, see that here, of 1 day. That's your sigma LT. Okay, well, 25 times 1 is 25. Yes, 25. Okay, good. For SKU1, the standard deviation in demand during lead time is 25. 25 times 1. And I could run over to the next page and start calculating the z-score, but you know, we're going to have to do this for each of the three, so why don't we just go ahead and do this for the other two. All right, SKU2. SKU2 is the case where daily demand is variable, but the lead time is constant, and I need to be careful. The standard deviation of demand during lead time, it's not the same formula. In this case, to determine what it is, I need the square root of lead time times the standard deviation in the daily demand. So, for SKU2, lead time is constant at 4 days. So I say the square root of 4 times the standard deviation in daily demand. An average of 25 units a day and a standard deviation of 5. That goes right there. So this is what? 2 times 5 or 10? Okay, good. We found the standard deviation in the distribution of demand during lead time for SKU2. It is 10. And notice that it's not the same as the first one. It's actually considerably smaller. Oh, you know what that means? It means, generally speaking, the second unit, the distribution or demand during lead time doesn't vary as much. Oh, okay. Now, we're still trying to fill out this table. The third one. Oh, the third one has variable daily demand and variable lead time. We still need to calculate then the resulting standard deviation of demand during lead time. Oh, but stand by. This is a pretty large formula. First, why don't I write it here? Need to take the lead time and multiply it times the standard deviation in daily demand squared, or the variance, also known as the variance in daily demand, except wait a minute. This is just one little exercise by itself, and that's multiply. You want to add that to another little exercise. Take the average demand during lead time, except square that, and multiply that times the variance in lead time, the standard deviation squared. Oh wait, there's more. When you're done with those two steps and you add them together, take the square root. Okay, that will find in the variable demand, variable lead time case, what is the overall resulting standard deviation in the distribution of demand during lead time. Oh, all right, so at this point we just need to fill this in. Okay, fill it in. Lead time is normally distributed with an average of 4, so that's a 4 right there, times the standard deviation in daily demand here is 5, except we're going to square that. So it's actually 4 times 25 in here, right? We want to add that to, let's see, average demand, daily demand is 25, except, careful, we want to square that, times the standard deviation in daily demand is, or excuse me, the standard deviation in lead time is 1. And we do need to square that, but that's just going to be 1. And then I do need to remember that is all 1 square root. That comes out kind of messy. In my notes, I get the square root of 100 plus 625, under the square root, or taking the square root of 725, which I got 26.926. I just took it out to 3 decimal places. Oh, okay, so this SKU3, this one has the largest standard deviation yet, although it's not that much larger than the first one. Okay, fine, now wait a minute. What was it that we were trying to do? Oh, we were trying to figure out the service level associated with reordering at 120 for each one of these items. Now we actually have here, here, and here, we actually have the pieces that we need. Because, let's go back. I was trying to figure out what the service level was associated with SKU1. I wanted to say 120, the target amount, the actual reorder point, minus 100, that is the average demand during lead time for SKU1, divided by 25, that is the standard deviation in daily demand for SKU1. All right, I did that, and I get 0.8. All right, and is that the service level? No, that's not the service level, but that is the means of finding out the service level, because we take that number 0.80 and we go to the z-table. That's why it's called a z-score. We go to a z-table. The first 2 digits tell us the row. Okay, 0.8, and then it was 0, because it was 0.8 exactly. That tells us the column. I'm looking right here, and it says 0.7881. 0.7881. What is it telling us? Oh, in the case of SKU1, look at the top of the table. 78.81% of the curve is to the left of that cut at 120. That's the service level. Oh, okay, so take this, go to table, and from table we see 0.7881, which is to say, because we like to speak in percents, that the service level for SKU1 is 78.81, 79 really percent. All right, now that's the service level for the first stock keeping unit. You reorder at 120 for SKU1, and 79% of the time you do have enough. What about SKU2? Just repeat these steps. SKU2, first calculate the z-score. 120 minus 100 divided by, now wait, let me check my workings, because what was the standard deviation? In the case of SKU2, it was 10. That's the number that I need. Oh, so the z-score for SKU2 just turns into 120 minus 120. 20 divided by 10, it's just 2. It's flat out 2. Yes, that's fine. Look up 2. Look up 2 on the table. 2.00 means that you're in the far left-hand column on the row 2. I see 0.9772. 0.9772, perfect. Just remember that number. 0.9777, that's 72, or 97.72%. That's the service level associated with the second stock keeping unit. So even though it has the same reorder point, 120, there's a higher service level with the second stock keeping unit. 98% of the time you'll have enough if you reorder at 120 because it doesn't vary as much. But anyway, to finish this off, we now have to do that same set of steps again for the third stock keeping unit. Okay, SKU 3, the same 120 minus 100 in the numerator for the z-score, but now my odd denominator 26.926. Remember, that's what I got for the standard deviation. So when I did that, I got, well, 0.74. Might as well round to 2 decimal places because that's what you're going to use on the z-table. Okay, 0.7 gets me to here, but then I want to look for 0.04. That's the column to stop at. That's right here. It says 0.7704. Okay, 0.7704 or 77%. The third stock keeping unit has a service level of 77%. So it's the one with the poorest service level, right? The lowest number of the three. So there, we've answered the problem. These 3 units, they each reorder at 120. That means it's the same amount of safety stock for each one of them because they have the same average demand during lead time. However, they don't have the same service level. The second item experiences the highest service level at 97.72%, and the third stock keeping unit experiences the poorest service level at 77 in a little bit %.